Hello, everyone. Thank you for letting me come and talk to you for a few minutes. My name is Charlotte, and it's been really interesting to watch all of you over the last 2 days. I am not a statistician person. I am a sustainability scientist, which means that I run around thinking up ways to save the planet. And sometimes when I go places, I can tell if I've hit the mark because people don't go running, screaming from the room. So hopefully you all will wake up and engage with me. So I wanted to talk just a little bit about my work. I have a master's degree from Georgia Tech in sustainable energy and environmental management. But I think sometimes people really are not have very little understanding of what sustainability scientists do. And a lot of it is we're really trying to connect the dots, find all of these different disparate elements that affect affect the planet, and connect them and to be able to make recommendations in many, many different circumstances and sectors. In the 10 or 15 years that my husband has been working with Bayesian analytics, I've had a ringside seat to really how information can be used for better decision making. And so I wanted to give you an example before I got started that in my world, we deal with so many different influencers. We get to deal with climate deniers. We get to work with people that are very siloed. So think about policymakers, community people. They're very, very invested, but they're very siloed. So one example that is important to me is extreme heat. So if you think about it, the way that extreme heat works, people think that it's just that the temperature rises, when in fact there are groups that are disproportionately impacted by extreme heat, and they include children, older adults, people with pre-existing conditions, athletes, outdoor workers, people like that. So sometimes when I present on extreme heat, policymakers, people that are actually running budgets, that are in public policy, will say things like, well, we need to make sure that we have enough cooling centers, or we need to have enough water available. And I always have to say, extreme heat is not a bottled water air conditioning situation. And that is what we do as sustainability scientists, that we want to look at adaptation and mitigation so that we can look at problems from the source. So I was frustrated. I've been doing this since 1996 and dealing with all of these gaps in information and how do you apply them, but also how do you achieve meaningful impact? I don't get to have as much fun as you do. I don't get to just look at theoretical problems. I get thrown into pit vipers where they're yelling and screaming. My point is more important than your point. Well, okay, but all of us are going to be sitting here in the middle of 50 below zero weather, and we need to work together to figure out those solutions. So often I'm spending time trying to get all of these different people to have a consensus and even to use their areas of expertise to collaborate and achieve innovation. So now, for the last 2 or 3 years, as Stefan can tell you, I've been trying to figure out, can I use Bayesian modeling to help me advise better? Because I don't want to be that person and say, I'm really a smarty pants about planet and I have all the answers, because I don't. My job is to go in and to help people discover why it's important and what are we going to do about it. So I'm hoping that I can get this video to run. I'm going to try. I got it. I have my mouse, but I don't see the click for my video. Right at the bottom. It's not running.
There you go.
Okay. We have no sound.
Is that how we know again?
It's probably not turned on the computer.
Okay, let me stop. Okay. Let's see.
Go back, click it again. Drag it back.
Okay. Still no sound. Hold on. Let's see. I'm gonna blame it on Stefan anyway.
Oh, okay. Yeah.
See. Is that 100?
Try it again.
Okay, so she has titles there, but part of the reason I wanted to share this with you is this is Greta Thunberg, and I consider her one of those sort of celebrity influencers. She has very little climate training, but people listen to her. And she really brings a lot of attention to some of the more pressing issues that we're dealing with. But at the same time, one of the reasons that I'm so excited about Bayesian is because of that very reason. There are tons and tons of misinformation in our space. And that misinformation hurts us as we're trying to figure out what are meaningful solutions. So you're looking at carbon credits or net zero, and the jury's still out because those emissions are still happening. So as we look at bridging sustainability science, in my mind, I'm trying to understand how do we manage uncertainty? And it's not just the fact of uncertainty, it's all these gaps in information. So today, I'm going to show you two examples of how I've used Bayesian. One is trying to explain scope 3 emissions and why they're so important and what's happening with them. And secondly, there's a utility that is grappling with this idea of a $20 billion project to impact 2 million families. Now, ordinarily, sustainability people and utility people kind of don't play well together. But since I've been doing this since 1996, my thought is there is no company with clean hands. And if we don't learn to work together, we'll all die together. Climate decision making depends on trying to manage that uncertainty and to do it with imperfect data. So first, let me explain, because someone reminded me yesterday that everyone doesn't know what these scopes are. So there's scope 1, scope 2, and scope 3 emissions. Scope 1 are just all those things that you do. All of it are anthropogenic impacts on climate. Scope 1 are just those things you do directly. So it's you in your house or it's your corporation and what they do that they can control directly. Scope 2 are those emissions that are generated by energy. So all the energy that you use, it doesn't matter what kind it is. It can be renewable, it can be gas, it can be electric. It doesn't matter. It's all related to energy and it's indirect. Scope 3 is the Mac Daddy. That's where more than 70% of all emissions are generated, and it's what we really care about. And so what we're looking at are all the different ways that we can both track emissions, but really we need to reduce emissions. And typically companies tend to favor mitigation over adaptation. And there are many reasons for this. And if you understand the difference, what we do know is that we do need both mitigation and adaptation. And I'll show you the difference in a minute. But for Bayesian, in my work, I started with also grappling with nodes. And we have nodes in our work too: supplier transparency, R&D, public policy, risk tolerance, so on. So here's a new one. We are now seeing two triggers that are decisive when we look at emissions. It doesn't matter which kind, scope 1, scope 2, or scope 3, but the Mac Daddy is scope 3. So now what we're looking at is both financial impact and insurance risk. So if you choose to not do anything, there is now a penalty for that. Perfect for Bayesian modeling. So this is sort of what this is going to look like, that we see of climate risk not as an either or probability of both physical and transition losses. Bayesian modeling can quantify that for us as a compounding effect. And so we tried to create this graph so that you could see what that might look like. So it's typical to look at emissions and how they occur over time. Now you have to add in this additional impact of financial risk as well as insurance risk. And while you're thinking about that, this risk that we're talking about that happens over time is multifaceted. And so again, it comes back to this whole idea of silos and one-track thinking. So we get experts, whether it's engineering or health, transportation, whatever it is. But for the planet, there's almost no one single impact, especially as it pertains to public policy. It covers so many different things, and we need to have a way to think about it. So I started with scope 3, modeling uncertainty. And the funny part is that I got invited to the American Chemistry Society 2 years in a row just to talk about scope 3. It was humbling to stand in front of a group of 300 PhDs in chemistry. 10 of them knew what scope 3 was. So when we think about these organizational nodes, maybe you think about them as being hierarchical, but really we have to think about them as drivers, right? Because as we look at all of these different triggers, these things that drive the issues around scope 3 emissions, especially, the Hellixia model helped us to identify these latent causes of adaptation neglect. In other words, what are those hidden things that could help us? And I have a really great example. So this is what the model, we started looking at it. And this Hellixia causal model helped us to understand the drivers to increase preference for mitigation over adaptation. In other words, in the blue are the triggers that lean towards mitigation, and the red is the various controls that would offset or minimize those challenges. In some cases, these triggers are independent. So for instance, if a company is paying a bonus for managers that can really control their emissions, or something in the supply chain, they can control those bonuses. So they could be withdrawn. That's the romance of mitigation. Whereas adaptation takes a bigger commitment for a company to say, we're going to look at this in a different way, and at the heart of adaptation is resilience. So in looking at scope 3 emissions, and green chemistry, here are those overlaps. I've highlighted them in green. So there are 15 types of scope 3 emissions, and I believe there are 12 that are green chemistry. But in green, you see this overlap. Fuel and energy-related activities, waste generated in operations, waste disposal, processing of sold products, and end-of-life treatment of sold products. And for my friend Jackie, water usage is big there. So when we look at those overlaps, it's important for us to see what are those indirect emissions that occur in the supply chain, and maybe we can leverage green chemistry to have a more meaningful impact. This is adaptation versus mitigation. I wanted you to see the differences between the two, and we do need both, but currently most organizations tend towards mitigation. So with the Bayesian modeling, it gives decision makers not just a choice, but a probability curve. So if you look at adaptation and mitigation, they can be treated as separate strategies, but in Bayesian, we can look at the model as conditional probabilities with a single climate system. And that's, for me, that gives me a really valuable tool. So now I want to give you a real life example, and it has to do with energy equity. So my thesis for my master's had to do with energy equity. And we got to look at a pilot program for Georgia Power for energy equity for 2 communities, one in Atlanta and one in Birmingham. But at the center of it were landlord retrofits were extremely difficult and in some ways were hidden. And so I want to show you why that matters. So what are the incentives for landlords to invest in energy efficiency? And so we wanted to put that into a Bayesian model. But we had our own nodes even before we did that. And they were finance mechanisms, utility, payers, building efficiency, energy burden, all of the above. This was our mapping. So this came from a bibliometric analysis that was developed by Nobel laureate Dr. Marilyn Brown. And this is that research. My job was just to analyze one thing, the role of landlords. So in many poorer communities, it's not just energy equity that is a function of a utility company, but it comes down to a landlord, the person that actually controls the building's function. So what we discovered is that out of all of these abstracts, landlords were only mentioned 10 times. This was a huge gap. And so we wanted to understand through Bayesian modeling, well, what does that mean exactly? And so we mapped it. It provided causal indicators that reinforce the incentives or challenges for landlords related to energy equity. So these hidden mitigation drivers equal short-term financial pressure, regulatory public policy, and siloed decision-making. In other words, this happens all the time. And so landlords who are directly related to energy equity are almost always left out of the discussion and the determinants for energy equity. These hidden adaptation drivers are limited adaptation metrics like tools and indicators, and view adaptation as a peripheral activity versus mainstream mitigation and lack of awareness. So as we looked at how we could start to maybe shift the narrative in the conversation, some of my conclusions were these invisible variables could be bias and misalignment that shape visible outcomes. In other words, our missing landlords. Utilities can forecast risk, allocate capital, and quantify social impact. But here's the thing, they don't do this in a vacuum. So they have guesswork to governance through probability. So hang on to this. If you're looking at this connection of energy equity, there's another model known as environmental economics. In environmental economics, what we're looking at are things called externalities. These externalities can be measured. So it can be impacts like health, it can be water consumption, it could be all of these things that contribute to the overall environmental impact, including the energy equity. We can measure that. But again, with Bayesian Climate Intelligence, it empowers this capacity building and human-centered decision intelligence. So I'm pretty humbled to get to do this, and it still feels like fish out of water to me. But look at it like this. If we can have more of these leaders who often show up with very little information, this we can give to them as a tool for capacity building and decision intelligence. The strengths are expertise across science, management, and policy, enabling professionals to translate uncertainty into measurable progress and innovation. That's my hope. So in conclusion, I'm thinking of it as knowledge, KPIs, and innovation. So I realize that I'm a beginner. I'm in the kindergarten when it comes to Bayesian, but this is my hope, that if we can provide better information, think about the people that are fighting right now in the Senate and in the House. Many of them make decisions because someone came in and gave them a briefing document. So pull that down to the municipal level, the state level, community organizations, many of whom have absent scientific intelligence. They are often making decisions with very little credible information. I think Bayesian modeling could change that. And I hope that I'll learn enough to help them do it. Thanks for listening to me.